My name is S. Ashok Kumar Reddy from 2nd CSA. Today my topic is about knapsack problem. Knapsack problem. Introduction to the knapsack problem. The knapsack problem is a classic optimization problem in computer science and mathematics. It involves selecting items with given weights and values to maximize total value without exceeding a weight limit. The problem can be applied in various fields such as resource allocation, budgeting, and logistics. Knapsack problem. Example: we have to take input n is equal to 3 and weight 2. Some values are given 10, 20, and 30. Weights 1, 1, 1. Output: we have to the maximum weight of knapsack is given 2. So we have to place from 30 and 20. Total output is 50. Problem statement: given a set of items each with a weight and a value, the goal is to maximize the total value in the knapsack. The knapsack has the maximum weight capacity that cannot be exceeded. The challenge lies in the selection of items to optimize the value while respecting the weight constraint. Types of knapsack problems. There are several variations of the knapsack problem, including the 0 by 1 knapsack and fractional knapsack. In the 0 by 1 knapsack, items cannot be divided. You either take the whole items or leave it. The fractional knapsack allows items to be broken into small pieces to minimize value. 0 by 1 knapsack problem. The 0 by 1 knapsack problem requires items to be selected entirely or not at all. This type is often solved using dynamic programming for efficiency. It is suitable for situations where fractional items are not feasible, such as packing bags. You have to observe in the 0 by 1 knapsack dynamic programming in the figure. Next, fractional knapsack problem. The fractional knapsack problem allows for items to be divided into smaller parts. This problem is typically solved using greedy algorithm for optimal solutions. It is applicable in scenarios like investigating money where particular investments can be made. Example scenario. Consider a scenario with a knapsack that can carry up to 50 pounds. We have three items to choose from: a gold bar, value $60, weight 10 lbs, a silver bar, value $100, weight 20 lbs, and a bronze bar, value $120, weight 30 lbs. The objective is to determine which items to select to minimize value within the weight limit. Items, values and weights. Item 1, gold bar, value $60, weight 10 lbs. Item 2, silver bar, value $100, weight 20 lbs. Item 3, bronze bar, value $120, weight 30 lbs. Calculating ratios. To maximize value, we calculate the value to weight ratio for each item. Gold bar ratio $6 per lb, silver bar ratio $5 per lb, bronze bar ratio $4 per lb. The higher the ratio, the more value the item is relative to its weight. Equivalent ratios. The value of ratio A is to B is to quotient A by B. Selecting items for the knapsack. Start by selecting the items with the highest value to weight ratio. In this case, we start with the gold bar, then the silver bar, and lastly consider the bronze bar. We must ensure that the total weight does not exceed 50 lbs. Calculating ratios. To maximize value, we calculate the value to weight ratios for each item. Gold bar ratio $6 per lb, silver bar ratio $5 per lb, and bronze bar ratio $4 per lb. The highest ratio, the more valued items is related to its weight. Adding items to the knapsack. First, add the gold bar 10 lbs $60 to the knapsack. Remaining capacity 40 lbs. Next, add the silver bar 20 lbs $100. Remaining capacity 20 lbs. The bronze cannot be added in full due to weight constraints. Exploring item. Since we cannot add the bronze bar in full, we can consider how much to take if fractional is allowed. We can take a portion of the bronze bar that fits in the remaining capacity. We can take 20 lbs of the bronze bar, which gives us the value of $80. Total value calculation. Total value in the knapsack $60 gold plus $100 silver plus $80 fraction of bronze. This results in the maximum total value of $240. The total weight of the items is 50 lbs, fitting perfectly within the knapsack. Dynamic programming approach. For the 0x1 knapsack, dynamic programming provides an efficient way to solve the problem. The approach involves creating a table to store maximum values for different capacities and items. This method avoids repetitive calculations and reduces time complexity. Greedy algorithm for fractional knapsack. The greedy algorithm works efficiently for the fractional knapsack problem. It focuses on selecting items based on the highest value to weight ratio first. This method guarantees an optimal solution in a shorter time. Next, complexity of the knapsack problem. The 0x1 knapsack problem is NP complete, meaning there is no known polynomial time solution. The dynamic programming approaches has a time complexity of big O of NW, where N is the number of items and W is the capacity. The fractional knapsack has a time complexity of big O of N log N due to sorting. Now, applications of knapsack problem. The knapsack problem has wide applications in finance, logistics, and resource allocation. It is used in budgeting to allocate limited resources to maximize returns. It also finds applications in project solution and cards loading. Real world example. In a logistic, a company may need to choose which products to ship based on weight. The goal is to maximize the value of goods transported while adhering to shipping constraints. This real world applications examples the relevance of the knapsack problem. And the conclusion, the knapsack problem is a fundamental problem with significant implications in various domains. Understanding its variance helps in applying the right solution method for optimization. The principle of the knapsack problem can lead to better decision making in constrained environment. Thank you, ma'am.